All right, now we're going to be working on absolute value inequalities. And you're mostly doing the exact same thing as you were with equations, absolute value equations. There's just one extra little tweak. So you want to get the absolute value bars by themselves. So if there would have been a number attached, you would have divided both sides. Or if there was a number over here being added or subtracted, you do the opposite to both sides. And then you're going to set up two inequalities. But remember, whenever you flip a sign of something on an inequality, the inequality sign needs to be changed. This is what I mean. So I'm going to remove the absolute value bars, and I'm going to say b divided by 3 is greater than or equal to 4. Notice I kept the inequality bar exactly as it is. Then I'm going to write b divided by 3. I'm going to put negative 4. This is now a negative. This sign flips, so we have to flip the inequality sign. And then you're just going to solve. So we're going to multiply both sides by 3. b is greater than or equal to 12. So solid line, solid dot. And b means, it means that b will be all of the values greater than 12. Then you've got this other inequality. We're still going to multiply both sides by 3. This says b will be all of the values less than or equal to negative 12. Again, solid line, solid dot. And that would be the graph of just a simple inequality like this. Now I'm going to come over here. And remember with absolute value equations, the fourth step was if the absolute value is equal to a negative sign, you write no solution. The same goes here. If you've got an inequality that's either less than or equal or less than a negative number, right away you can simply say no solution. You don't have to take it out and do two separate equations. However, be very careful about that. Don't get too excited and think, oh great, that'll be easy because we can just save on doing a lot of work. This is what I mean. Notice there's this negative 3 attached. Even though this says less than or equal to negative 27, when we divide both sides by negative 3, that becomes a positive, and then you'd have to remember to flip the inequality sign. So be really, really careful on those. Because remember, right here, we're dividing both sides by a negative number. This was a negative 27. Whoops. Except for your teacher would have to know how to do divide. Math okay. This now is a positive number. So that inequality sign needs to flip. And now you're going to take it out of the absolute value bars. Remember to flip that inequality sign. And then we're going to subtract 9 both sides. 4x is greater than or equal to 0. When you divide both sides by 4, we're just going to get x is greater than or equal to 0. Because look, 0 divided by 4 is still going to be 0. So right up here, x is here. I'll make that a little bit smaller so we can see that. X is greater than or equal to 0. So solid line, solid dot, and then right here we're going to subtract 9 both sides. 4x is less than or equal to negative 18. We're going to divide both sides by 4. X is less than or equal, well, that's the same thing as negative 9 times 2. 2 times 2, the 2's cancel. Negative 9 halves, which is the same as negative 4.5, 4.5. And this says x will be all the values less than or equal, solid line, solid dot. Just like that. All right, that's it for absolute value inequalities.